Welcome to Module 12, Configuring Windows. This module covers Core A plus 2201-202 skills, including configuring Windows user and system settings, installing applications, and using productivity tools. By the end of this module, you will be proficient in configuring both Windows user settings and system settings. These outcomes map directly to the lessons ahead. Lesson 12.1 focuses on Windows user settings. This content corresponds to A plus 2201-202, Objective 1.6, which covers the configuration of Microsoft Windows settings. In this lesson, we will learn how to adjust privacy settings, change the system date and time, manage ease of access options, and view hidden files and folders in File Explorer. To adjust privacy settings, navigate to Windows Settings and open the Privacy and Security menu. Here, you can manage individual app permissions for features like the camera or microphone and control data sharing. To change system date and time settings, go to the Time and Language menu in Settings. You can configure time zones, adjust for daylight savings, or synchronize with an internet time server. The Ease of Access menu offers tools across three categories: Vision, which includes magnifier and narrator, Hearing for audio and caption settings, and Interaction for keyboard and mouse accessibility. To view hidden files, open File Explorer and toggle the Hidden Items checkbox under the View tab. For more advanced options, use the File Explorer Options menu. This lesson provides an overview of various Windows user configuration areas, including the Control Panel, Desktop Settings, and Indexing options. Windows 10 and 11 feature different interfaces. Windows 10 uses a left-aligned Start menu, while Windows 11 defaults to a centered taskbar and a simplified Start menu design. This visual demonstrates the Windows 11 desktop, highlighting the centered taskbar icons and the clean, updated interface design. In contrast, this is the Windows 10 desktop, characterized by the familiar left corner Start menu and traditional taskbar layout. Windows 8.1 introduced the tile-based Start screen, marking a major shift in how users interacted with the operating system at the time. Windows Vista introduced the Aeroglass visual style, bringing transparency and advanced graphical effects to the desktop environment. Finally, Windows 7 refined the visual elements of Vista, becoming one of the most widely used and stable versions of the Windows operating system. Let's take a trip back in time to Windows XP, famously recognized by its blue taskbar and the green Start button. It remains one of the most iconic and long-running versions of Windows ever released. Next is Windows Millennium Edition, or Windows ME. This was a consumer-focused release from the Windows 9X era, serving as a bridge between the classic Windows 98 and the move to the more stable NT architecture. Windows 2000 was built on the robust NT kernel. Unlike previous consumer versions, it was engineered specifically for business and professional environments, where stability was the top priority. Windows 98 evolved the interface first seen in Windows 95. It offered significant improvements to hardware support and brought deeper integration with the growing internet. Windows 97 was a less common interim update within the Windows 9X family. It focused primarily on refining the interface established by its predecessor. Windows 95 was a landmark release. It introduced the Start menu and the taskbar, foundational design elements that have shaped the Windows user experience for decades. Released in 1993, Windows for Workgroups 3.11 was significant for bringing peer-to-peer networking capabilities to users, still operating as a shell on top of MS-DOS. Also appearing in 1993, Windows NT 3.1 marked the start of the NT family. This system was designed for the workplace, offering professional-grade stability separate from the DOS-based consumer line. Windows 3.0, released in 1990, was the first version of Windows to achieve widespread commercial success, finally providing a reliable graphical interface for DOS users. Windows 2.0 arrived in 1987. While it was still considered primitive by modern standards, it was an essential step forward in the evolution of graphical interfaces. Finally, we have Windows 1.0 from 1985. It was the very first step into the world of Windows, acting as a basic graphical shell running on MS-DOS. In modern Windows, settings are managed through two main interfaces. The Settings app provides a touch-friendly, category-based experience, while the Control Panel remains as a legacy tool for advanced configuration tasks. This is a view of the modern Windows Settings app. Notice how it is organized into logical categories, which makes it straightforward for users to find the specific system or device settings they need. Here is the classic Control Panel. Even today, it is still the primary location for specific legacy tools like the Device Manager or advanced administrative settings that have not yet transitioned to the new app. Lastly, let's cover user accounts. Administrators hold full system control, while standard users have limited privileges. You can use local accounts for device-only access or Microsoft accounts to sync settings across multiple devices. Let's take a look at the Account Settings screen. This interface allows you to manage your user profile, choose your account type, and configure various sign-in options to secure your device. Privacy settings help you control your data. This includes telemetry and diagnostic reporting, activity history, and your advertising ID. You can also manage app-specific permissions, like access to your microphone, camera, or files, as well as configure security features like Windows Defender and Firewall. Desktop settings are split into two main areas. Under Time and Language, you can manage date, time, and regional formatting. The Personalization menu allows you to customize the look of your system, including themes, wallpaper, the taskbar, and color modes. Ease of access settings improve accessibility. They cover vision tools like the magnifier and narrator, hearing options like closed captions and visual alerts, and interaction features, including the on-screen keyboard, speech recognition, and support for specialized input devices. File Explorer is your primary tool for navigating files. It manages system objects, folders, and drives. While many system files are hidden by default for safety, you can reveal them through the View menu if you need to perform advanced troubleshooting. You can further customize File Explorer behavior in the Options menu. Here, you can adjust how items open and change folder views. The View tab also lets you toggle the visibility of file name extensions, hidden items, and protected operating system files. Indexing options are essential for search performance. By creating a database of your files and emails, Windows can return search results much faster. You can manage which locations are indexed and troubleshoot search issues by rebuilding the index if it becomes inaccurate. Finally, practice these concepts with real-world scenarios. Block app microphone access, adjust your system time zone, enable high-contrast accessibility settings, or locate hidden system files. These tasks are key to mastering Windows configuration. Welcome to this video on Windows system settings. This lesson covers key configurations for managing your Windows environment, aligned with CompTIA A+ certification objectives. In this video, we will explore the information found on the System Settings page, default Windows Update settings, power options like Sleep and Hibernate, firewall rule sets, and how to access administrative tools. The System Settings page provides a comprehensive overview of your device. This includes your computer name, Windows edition, processor and RAM details, system type, product ID, and activation status. Windows Update is enabled by default. It automatically manages critical security patches, while feature updates can often be scheduled or deferred. You also have the flexibility to pause updates temporarily. Understanding power options is essential. Sleep keeps your session in RAM for a quick resume with low power consumption. Hibernate saves your session to the hard drive, using no power, which makes for a slower but more reliable restart. Windows Defender Firewall utilizes two main rule sets: inbound rules, which control incoming traffic, and outbound rules, which manage outgoing connections. These can be customized by program, port, protocol, or network profile. To access administrative tools, you can navigate through the control panel or simply search for Windows Tools in the Start menu on Windows 10 and 11. This menu contains critical utilities like Event Viewer and Task Scheduler. This lesson covers a broad range of system settings, from security and device management to sound configurations, power options, and advanced administrative tools. System settings include 5 key areas: device configuration, power and sleep management, system information, advanced performance settings, and remote access along with notification preferences. Update and security settings manage your update lifecycle, ensure threat protection through Windows security, and verify your Windows activation status for full feature access. For hardware, Plug and Play automatically configures devices. You can use the Bluetooth and devices settings for general management, or rely on Device Manager for more advanced driver and troubleshooting tasks. Whether using the classic Devices and Printers applet or modern settings, these interfaces provide multiple ways to view and manage your connected hardware and drivers. Display settings allow you to optimize your workspace. You can adjust scaling for better readability, calibrate color accuracy, arrange multiple monitors, and configure resolution and refresh rates. Sound settings are managed through the Sound applet for basic volume and device selection, while advanced settings allow for sound enhancements. Troubleshooting tools are also available for resolving audio issues. Finally, power options help manage system state. From ACPI power states like Sleep and Hibernate to customizable power plans, these settings help balance performance and energy efficiency. Let's look at apps, programs, and features. Windows offers various ways to manage software, including optional OS components enabled via the control panel and store apps that run securely in a sandbox. We also distinguish between user context applications, which install per user without admin rights, and traditional desktop programs that install system-wide and typically require administrative privileges. For developers and system administrators, the Windows Subsystem for Linux, or WSL, enables running Linux distributions directly inside Windows, providing access to command line tools for cross-platform compatibility. The App Settings menu in Windows is your centralized dashboard for managing installed applications, toggling startup apps to improve boot speed, and configuring specialized tools like the Mail applet or gaming modes. Network settings are split between the Modern Settings app for status and adapter properties, and classic control panel applets like the Network and Sharing Center for advanced file and printer sharing configurations. Security and internet settings are also key. Windows Defender Firewall allows you to manage traffic rules by profile, while the legacy Internet Options panel lets you fine-tune browser security zones and privacy settings. Administrative tools like computer management, disk cleanup, event viewer, and the local security policy are essential for troubleshooting, system maintenance, and configuring security audits on standalone PCs. Finally, remember these navigation shortcuts. Use Windows plus X for quick access to system tools, instant search for launching apps, and Windows plus R for the run dialog to quickly execute system commands. Welcome to this video on installing and configuring applications. This lesson covers Exam Objective 1.10, which focuses on installing applications according to specific requirements. By the end of this video, you will be able to identify minimum system requirements, explain common application distribution methods, evaluate necessary pre-installation considerations, and understand the risks associated with installing software. When determining if a computer meets the minimum system requirements for an application, you must check the operating system version, processor speed and type, memory, storage space, graphics capabilities, and network connectivity. Applications are distributed in several ways. While physical media like DVDs and USBs are less common today, modern methods include direct vendor downloads, app stores, enterprise deployment tools, and open-source repositories. Before you begin an installation, evaluate your specific needs. Verify compatibility with your OS, review licensing and costs, assess the trustworthiness of the source, and ensure you have the required administrative permissions. Be aware that software installations carry risks, including potential malware from untrusted sources, system instability, performance issues due to high resource usage, and security vulnerabilities. Always prioritize trusted sources. In summary, remember to check your hardware and software requirements, choose your distribution method wisely, perform a thorough pre-installation assessment, and mitigate potential security or stability risks. When reviewing system requirements, look beyond just the basics. Consider the CPU's specific features, the need for a dedicated graphics card with its own video RAM, and whether the app requires external hardware tokens for authentication. OS compatibility is crucial. Ensure your application version matches your OS. Be prepared to compile software manually if necessary on Linux, and remember that 64-bit applications strictly require a 64-bit OS and CPU. For distribution, you will encounter various file types like EXEs or MSIs for Windows, and DEB or RPM packages for Linux. Always verify the authenticity of these files using digital signatures or hash values. Consider the broader impact of installations. This includes licensing and training costs for businesses, the potential for network congestion when deploying tools across many systems, and the risks of using improperly vetted software. This next section introduces Lesson 12.4, which covers cloud-based applications. This maps to Exam Objective 1.11, concerning the installation and configuration of cloud-based productivity tools. By the end of this lesson, you will be able to define cloud-based applications, compare them to local installations, identify the benefits and drawbacks, and provide examples of common tools used today. So what exactly is a cloud-based application? It is software that runs on remote servers rather than your local machine. You access these programs through the internet, while the provider handles all the infrastructure, storage, and maintenance. Comparing cloud-based apps to local ones. Local apps run on your hardware and offer offline access, whereas cloud apps rely on the internet. Cloud providers handle your updates, whereas you must manage those tasks locally. Cloud-based applications offer flexibility, scalability, and automatic updates. However, they do introduce dependencies on internet connectivity and potential concerns regarding data privacy and security when hosting your files with third-party providers. Examples of cloud-based applications you'll see today include productivity suites like Microsoft 365 and Google Workspace, collaboration tools such as Slack, Zoom, and Microsoft Teams, and storage services like Dropbox, Google Drive, and OneDrive. This lesson also covers essential cloud services, email systems, storage solutions, collaboration tools, user licensing models, and identity synchronization, all of which are critical for managing modern enterprise environments. Cloud-based email enables seamless access, synchronization, and collaboration across all your devices. Unlike on-premises Exchange servers, these solutions do not require local infrastructure, which significantly lowers your overall IT maintenance burden. Cloud storage provides access to files from any device with internet connectivity. Examples include iCloud, Google Drive, and Microsoft OneDrive. File management apps like Dropbox further simplify how you share and synchronize your work. Collaboration tools are essential for modern teams. This category includes real-time document editing, video conferencing platforms like Zoom, and messaging apps like Slack, all designed to keep your projects moving efficiently. User licensing for cloud services often involves subscription models, such as Microsoft 365 or Adobe Creative Cloud. These come with specific terms, conditions, and compliance risks that you must manage to avoid penalties or loss of access. Remember that some licenses include ownership clauses that define who owns the content created within the platform. This is a crucial distinction for your organization when choosing between personal and commercial licensing. You will typically assign licenses through administrative portals, like Microsoft Entra. If a user encounters an issue, the fix is usually as simple as updating their assigned license or reinstalling the relevant application. Finally, identity synchronization via single sign-on, or SSO, allows users to access both cloud and on-premises systems with one set of credentials. This improves security and efficiency by reducing the need for multiple logins. To wrap up this module, Windows settings handle your basic preferences, while cloud-based tools extend those capabilities with collaboration and synchronization. Understanding both is key to mastering modern IT environment management.